as usual, the BoF is for you, for the people that are here that want to talk about glibc. I want to talk about glibc. Do you want to talk about glibc? We could talk about malloc. We can talk about other things. I have slides. Stephen, what do you want to talk about?
Extended time slice conversations going on in the kernel.
For RSec, no?
Well, using RSec, but that's, yeah, it's on top of RSec. But it's a new feature. It's not restartable sequences. We just happen to be using the RSec interface. So basically, it's a commute way for user space to say, I'm grabbing a spin lock. Please don't preempt me if you can. And the kernel will try to, even though its time slice might expire, it will say, okay, you're in a critical section. It doesn't have to be it was just any critical section. Give the process a little longer to release, considering like these short, like, you know, a lot of times like SQL has spin locks that are really, really tight, but if you get preempted and then say if the owner, or basically if you get preempted, if you have a spin lock and you get preempted and then someone else wants to grab your lock, you just spin waiting for it and just wasting CPU cycles. So this is a way to help mitigate that. So the question is the glibc...
What did Thomas Gleichner think about this?
He's writing the patches right now.
He's right, okay. Because I'm like, he had the strongest opinions about probably work like this.
Peter Zilstra actually had the strongest, but I think, yeah, but it was Thomas, I think, that kind of like helped, because actually Thomas and I actually agreed about a lot, so.
What? I can see how that's useful. I mean, in user space, we've often had to do exponential backoff, some spinning, some use of wait primitives. What are you asking from user space in order to make that effective and to mark it up?
So basically it's just, I'm letting you know about it.
Yeah,
so when you go into these critical sections, if you have RSec already there, just tell the kernel, I'm just basically...
So you use the restartable sequence and the per CPU data that you have access to from it to write.
So basically it's just a memory location in the RSeq will define the memory location of where, you have to update a value to say, just to tell the kernel that so you might just update a value and then remove the value, update the value, remove the value while you're in it. And if you just happen that time slice were to hit at that moment, the kernel may say, oh, you're in a critical section, don't preempt you right now, let you run. And then but the thing is, the kernel will then notify you saying, we're giving you extension. So when you see that, when you release it, you'll notice, oh, we got an extension. We have to make a system call to preempt. Otherwise, we're going to start getting punished. So basically, if you just ignore it, if you set I'm in a critical section, but then don't do anything after when the kernel extended you, and you don't call system.
Because I mean, you need to re-enter the kernel at that point to give back what you were just doing.
Yes. Otherwise, the kernel
is that scheduler dependent?
It could be right now. Okay, so I haven't looked at the latest patches, but like a sched yield or whatever you need to do, like just do any system call that will just say.
Okay.
Well, is it now something completely different now? Is that John? You looked at the latest patches.
It's a special system call.
Oh, they're adding a new system call for this?
Yeah.
Oh my
God. An arbitrary system call to get terminated.
Hey, here, you want the mic, John?
Yeah.
There's a new RSeq sched yield system call. It's just for the purpose of saying I'm done with my critical section. That doesn't necessarily give up the CPU the way sched yield does. Right? It gives the kernel the option of taking it from you. Mm-hmm. And
but I mean, sched yield behavior is scheduler dependent as well. The schedulers.
Sched yield is scheduler dependent. I'm saying this new.
Yeah.
This new thing is just to say. So basically, is this? In majority, like 99.99% of the time, you'll set a bit and clear a bit, set a bit, clear a bit. You never got, because it's always so short, you never got preempted. Say if you you set the bit, but you do get just that 1.001% of the time you get preempted. The kernel will notify you. So we'll update this variable. So when your variable, oops, did it just crash?
You didn't yield.
Exactly. You got punished. Anyway, so basically you set the bit or that you're in the critical section, and when you clear it, you'll notice that, oh, you've been preempted, or you actually got the extension. So to be a good citizen, you call this rseek yield, which tells the kernel, okay, you're done with the critical section, we can preempt you normally. And it's just a normal, you get preempted. So if the kernel's like, oh, maybe we migrated the task around and we don't want to preempt you anymore, or something happened, you will just continue again. It just, basically, it's like just notifying the kernel that I'm done. Thank you for giving me the extension. I'm done with my extension. Now you could preempt me if you want me to. But if you don't do that system call, and you get and then you go to a full time light, then the kernels might going to say, oh, you're being kind of malicious, and start shortening how much time you run. So you should let the kernel, this is something so that you should be a good citizen to do this. Otherwise, the kernel won't take kindly to abuse.
I saw the discussion. I haven't had time to respond to it, but my question is, why was this approach chosen and not the other direction? Like, you have the ability to query whether you are near the end of your time slice, and then avoid entering the critical section.
Well, then you need a system call.
Sorry, what do you mean?
You need to do a system call to that query, don't you?
No, you could get that from the ASIC area as well.
I mean, that's too much work on the schedule. Like, we're not going to, this is user space memory. That that could actually be swapped out. So, the communication thing, like the rseek is not guaranteed to be, it could be swapped out, it could be anything, so it might have to be faulted in. The point I'm saying is, so in the scheduler, because the scheduler update for how much time you have, we're going to be constantly updating all the tasks with special memory, so we have to update some address. That's kind of a lot of overhead to have. To notify
not constantly. I mean, only when the time slice expires for that. It's about to expire for that.
Well, you say about to expire. We don't have a about to expire. We have expired, and you have.
But you have an about to expire now when you say, okay, you get this extension.
No, it's you expire, actually expire. So basically, when you go into a critical section, we don't know where you are. You just say, I'm in a critical section, I'm not. 99.99% of the time, the kernel will never know, because you're just, I'm in a critical section, I'm not, and the kernel will never know. But it just happens that, say if I go into a critical section, now your time's like expired. It's not about to expire, it expires. So it preempts you. But then it says, oh, you're in the critical section. We'll give you like 50 more microseconds to get out of it. So it will then go back to your space, you get to run, and ideally, you don't spend 50 more microseconds for these locks. And then you say, okay, you see that you got preempted. And the kernel gave you an extension. Now, when you're out of the critical section, you just say, okay, kernel, thank you very much for the extension. I can just do this special system call, and then you get preempted normally that you would have without this feature.
Okay, so the assumption is that you basically spend no time in critical sections, because
right. You don't, because if you get preempted in a critical section, now you're more likely to cause contention, and it can build up.
Yeah.
Because if you get preempted in a critical section, someone else wants to grab the slot. Now they're
No, I mean that when the kernel schedules, tries to reschedule the process, and most of the time it's not going to be in a critical session.
Right. Most of the time it's just going to preempt you, so you're not going to be in a critical section. So this is only in the case, so when a normal time slice goes off, likely you're not in a critical section.
Okay.
So this is just, this actually came back from a Linux Plumbers conference I had when we were at Santa Rosa. I talked with, Postgres maintainer, Raj, I don't know his name, but one of the maintainers from Postgres who told me about this issue. I don't know who this is. Yeah, right.
So the idea originally came from Postgres complaining about spin locks, and we're saying the issues of being preempted, where it does every so often cause a spike in latency. They said the majority of times they don't care, but it does have an issue, and we're looking, and we discussed several ways to do this, and with the new preempt lazy code that came up, I realized that we could use this feature to implement this. And that's why I did the first implementation, Peter Zylstra had issues with it. And then it went through various different other people, and now Thomas Gleichner is the one pushing it through. But the thing is, we need to get glibc to know about it, or otherwise we don't want to implement something that no one uses. Yeah.
Doesn't that make every lock? Doesn't that make every lock more expensive? I mean, with having to call a syscall right after you've come through that?
No, you only call the syscall if you are preempted.
You have to go back and check, Peter. So what ends up happening is you set your bit, you say I'm in a section, then you clear the bit. But when you clear the bit, you're going to observe another bit change that you go, oh, the kernel waited for me to complete my task. And when you do that, you have to say, I have to thank the kernel, and if I don't thank the kernel, it punishes me.
Yeah. So you only do it when there is when you got extended.
Yeah.
So it's not clear to me.
Ed Hemmerwall, may I interrupt for a moment?
Go ahead.
So I only want to note that we did spend 10 minutes talking about the topic, and the BoF is for everybody, and but you are everybody. You, Stephen, we include you. But so do you want to finish a comment on this discussion, and then we can open the floor again to things anybody else wants to talk about?
It's just that it's not clear to me which interfaces are you aiming to use this new framework?
Anything that has a critical section that could cause contention elsewhere.
Yeah, but do you think that something like pthread lock or more,
like a spin lock?
Spin
Yeah.
locks only.
Yeah, because
anything that actually mutex on contention, if you go to the the kernel anyway.
I'm asking because pthread spin lock is not used anywhere on real workloads. People will try to come up with their own spin locks because fairness. And internally, we don't use spin locks at all. So the question is, do you need something else to provide to users? Do we need a new interface? Or it's just, do we need to set up something so users can use this without glibc messing up with their own projects?
Well, yeah. I mean, you could put it onto mutexes because some users just use mutexes like short-lived locks. They just take the mutex, do a little bit of work, and then unlock the mutex, and then they walk away. They could have used a spin lock in that case, and so we could mark up both mutexes and spin locks with this. There's no downside because mutexes with a few texts a day will simply do user space level atomics unless they have to wait, right? If they wait, then we don't care.
The only thing is you have to care about is the length if you're holding this, because if you're holding it for longer than 50 milliseconds, or microseconds, then you should not be using this because the kernel will start punishing you.
Okay.
So that's why it's for short.
Then maybe not, yeah. But then as Ed Hemmerwall notes, it's probably right. There's pthread spin locks don't get used that often from a workload perspective. Yeah. All right.
Yeah, I mean, we don't really know how the existing spin locks are used when they are used, and they could not be contended and have actually longer critical sections than what you are expecting for this. So putting that into the existing API seems to be a bit.
Unless you have a new flag or attribute or something like that.
Yeah, could have. But do you want to have like this kind of dispatch in the spin lock code? Then that doesn't seem to be great. We do have internal spin locks in some condition variable locking code, I believe, or comments that we should spin a little bit.
We
And I
do
think-
in pthread convar. There are algorithmic internal details that require us to spin.
They could be extended to use this because we know that we know how long we are going to spin there, and
Algorithmically, they're very short-lived critical sections in convar where we want to get a sequence out of this, and you have to spin, and you have to get your sequence number, get the token, and then do something else. And in that case, we could try, I guess. Yeah.
I actually need to talk to those database folks. They're the ones that probably most likely use it. So
Yeah.
I figured to bring it up here.
Yeah. And I think there's a case for database that many of the databases have written their own locking implementations. Well, because it just serves their purposes better rather than POSIX threads or ISO C or ISO C++, which are kind of generic. They're either using Futex directly or not. Which could lead to another topic, which is like, should we just add Futex and other kernel wrappers? We have not to date added wrappers in glibc for C access directly to the Futexes, simply because of the complexity of the Futex API. We can add it, and then it'd be C callable with all its parameters. I don't think it'd be hard. I mean, why have we not done it in the past? Usually because we said there's no easy way for users to use it, but at the same time, we've said if the kernel defines an interface, it simply makes it easier for other people to use these interfaces in this way. Yeah. At Hammerball?
I recall it's because we didn't define the correct API to export to the userland. It's not clear that should we export a naked Futex call and the user will create the constructions required, like Futex wait, Futex whatever, and or should we provide predefined Futex operations wrappers so users are only able to call Futex with certain operations?
For quite a long time at this point, we've had a kind of blanket consensus that we really should just be adding the raw kernel syscalls as they are, because the kernel developers have built them, they've designed them, they are what they are. They're not going to change from a syscall perspective if we export them. It simply makes it easier for other people to use the C library C interfaces to build perhaps other interfaces on top of them. So by not providing it, we also don't allow for experimentation at the next level of like C library callable interfaces.
But Futex is a little bit different because it's a dispatching interface with many different sub-operations and different argument profiles for the sub-operations. So yeah, there's the kind of conformance issue that you might pop off arguments from the stack that don't actually exist if you write a generic wrapper like that.
It's the same as IOC.
Are you saying if
is-
glibc provides a generic version?
Yeah, it is like socket call, for example.
Yeah.
Yeah, socket call.
But at the very least, we would be doing the consideration and then making it available for someone else to then experiment on top of the interface. Because today what has to happen is people end up just using syscall or having to write assembly wrappers for it, which doesn't support experimentation in the rest of user space with those interfaces. And I do think that the people in this room and the developers working on glibc would be the best place to actually write the wrappers as they should be in order to access the raw kernel functionality.
If you're going to do something like this, what I would really love someday is have a way to tell the kernel through memory or whatnot who the owner is of us. Because I believe right now, Futex is there's no system call. You get a lock, you kind of like never make the one reason why it's fast is because you don't have to make a system call. You just change owner. And if there's some way to have who the owner is, if someone blocks on it and says, okay, I need to spin, or instead of sleeping on a Futex, usually on contention, you go to sleep. And this is where I was talked to the Postgres folks. He says Futexes are too slow because every time you hit a contention, by the time it went to sleep, the lock was already locked, and it was just so their benchmarks were horrible because by the time you get back woken up and come up, it would have been just quicker if they just spun. But if you're able to expose the owner, then you could, when you go to the kernel, you could actually say, is the owner still running, or did it go to sleep? If it went to sleep, there's no reason to spin, you just sleep. But if the owner is spinning and you still have time slice, you spin, like it's called adaptable mutexes. We implement this actually in the kernel, and it actually helps improve performance, where when you get the lock, since the idea is if you're holding the lock, you're going to release it soon. So if the owner is running, wait for it to release it instead of going to sleep.
Yeah.
So if we could expose somehow, if we have
But
some
you're
way
saying
of
Futex wait doesn't know the owner. Well, but I mean, the owner's the caller. It's the TID that called the syscall.
No, it's the block. It's the
Ah, yeah.
Yeah,
You're
yeah.
saying the owner of the thing you failed on. Yeah.
Yes.
I mean, technically, we record the owner, but it's in user space, so it's in user space memory.
If we could find a way to export, I would love if we could find a way of finding that. Then the kernel could actually do some more. Instead of sleeping, could say, "Oh, let's wait till this guy's still running, continue to run." But it's a design disaster.
If I'm honest, I don't know what we do with the adaptable mutex today, because we technically,
So
I thought POSIX had one.
For recursive mutexes, at least we write the idea of the owning thread into the footex work
Correct.
today. So
But I don't think that's not a contract.
No.
There's no.
they are
this is
like
the
for
way it is.
PI stuff, it's a contract.
Was it?
For P,
Oh, for the PI, yes.
yeah, but we could add another flag, and then say, okay, this is now part of the contract. So.
But how would that flag make it to the kernel? I think would be the broader question. So we went from adding syscall for futex to adding an extra parameter, but
Yeah, I mean, we could set it unconditionally in the malloc implementation, I believe, but that is
sure,
something
interesting. Yeah.
to take offline.
Any other topics that people want to talk about? Oh, Maxim, do you have another topic? A different topic? Is it CI related?
Hi everyone. No, let's make glibc buildable with Clang.
So HJ Liu has been working on making the test suite build with Clang. Ed Hemmerval has a branch that makes glibc buildable with Clang. I think it is absolutely a great idea to support other tooling, to support other build environments. I think the difficulty is simply the amount of change required, the number of patches. I think your tree at Hemmerval is like 100 commits or something in order to change some pieces of infrastructure. It's just not straightforward. So it is work, and I'm supportive of it. And so, like, I will mention that Ed Hemmerval has made a great suggestion, which was attempting to focus patch review on a monthly basis. So right now, glibc, we do a weekly patch queue review in order to try and make progress against like large submitted patch blocks in order to make progress on certain features. Ed Hemmerval's suggestion in the past, which I haven't done a good job following as I lead the patch queue review, hold me accountable to it, which is we pick a topic for the month, and that month we really try to like burn down that topic, get all the patches done for that topic. If we're doing a cleanup in a particular subsystem, we get everything done in that subsystem. Like you have the SegEV thread cleanup that's there, we got core math, so we could choose like, October is core math month. And like a bunch of us spend a bunch of time supporting the core math cleanup and evaluating performance, because what ends up happening is we drag some of those core projects so long so that we have really good work that I think gets stuck in the patch queue review. So we've improved from the point of, now we're consistently looking at what needs to be reviewed, to now we're looking at what needs to be reviewed with a focus in a particular area to make forward progress so that you get consistently fast review on your patches. How could we get through that 100 commit backlog to enable building glibc with Clang?
So it's a bit less now that because AJ work. So I think it's 50 patches to enable the build and more 20 to fix some regressions. But I think the main problem is that some patches got stalled because it's some code sharing with GCC, and GCC is not willing to add the support. But since we sync then some shared file, if I try to make the change in glibc, Joseph has asked me to do this first on GCC, and this is going on and forth, and it's unproductive. So I need some closure. What happens if GCC is not willing to take the change, but it's something that we might want to have this locally on glibc?
Cross-project collaboration is always difficult and is a point where we have to consider the other project's views. Sid has his hand up though, so we should hand the mic to him and he maybe has a comment.
So is there a subset of the patch set that is not contentious and can be kind of staged in? I mean, if it's 100 patches, surely there's like 40 of them that we could kind of get in, and then we talk about the 60 one at a time or 10 at a time. Is that possible?
Well, that's like standard practice, right? Pull out the things that are not controversial, get them moving, and then iterate on what's left.
Yeah, I'm already happy. I've already promised Adam that I'd review most of it. It's just time, and it's one of those things where, like, because it's been so long running, it sort of falls down the list because it's, you know, like, did we really need it in 2.42? No, and then S-frame sort of took up my attention, but no, I think it's fine. I think there's most of it is uncontentious. They sort of fall into a few categories. A lot of them end up touching like old GCC workarounds and stuff as well, where we sort of have to decide if we're going to extend them or just drop them entirely. But yeah, no, I think if you could batch them into contentious and non-contentious, I can look at the non-contentious ones and I'll finally get that part done.
From a Gen 2 perspective, I have a question for you, Sam. Are you using or testing those? Do you have because I know Gen 2 will have a build where like everything got built with Clang, or a build where everything's built with some feature flags set. Is anyone testing the patches from a distribution perspective?
We can. There's interest in it, but at the same time, it's hard because my focus is on the GNU side. So I sort of we could do it. It's just a matter of.
I just didn't. My question was there anyone on the toolchain team that was looking at it or evaluating it? And if the answer is no, then
I think
it's no.
There's someone I have in mind who I could probably delegate it to. Yes, if that would be useful. Because I guess you're worried about what, headers breaking or what?
Yeah, I mean, I think we haven't tested this. So as soon as we put it in,
yeah, okay, fine.
The next step then becomes you're trying to build distribution pieces with it. Someone will use it distribution pieces with it.
Give it to Ralph. And
yeah.
I mean, we do build at the moment installation stages with pure LLVM and with Muscle that works also without GCC.
Mm-hmm.
And for the glibc builds, we basically pull in the GNU 2 shell as well and use that exclusively for glibc.
Yeah,
okay.
So we could easily just cut out the GCC part for those, and that would provide decent testing, I think. So yeah, we can do that.
I mean, like from an outcomes perspective, the question would be like, if we say that this is now a way that you can build glibc, there will be users that will want to do that, and then they'll come back and talk to us. So if we have tested it and we have some confidence that we didn't break things, then that's better.
I think we can do enough to get it at the point where we say in this release it works, and then we probably we could do some sort of baseline testing afterwards, but we'd rely on people to tell us afterwards. But there would be users for it, so I'm not worried about that.
Yeah. Okay.
I guarantee that somebody will jump at it.
Yeah.
Yeah.
Well, I think people wouldn't jump at it for years.
So, Ed Hemmerval, then maybe we'll pass the mic back to you. So then there's 50 patches that you have left. I'm always happy to make a focus of one of our months getting the patches reviewed and done.
So I have another topic.
Sure.
So yesterday someone asked me which is the most technical depth we have on glibc, and we have a bunch of them. And one thing that come up in my mind is stdio implementation, which leads me to the question, for how long should we keep compatibility to an ancient GCC version that, okay, someone cares about, but the rest of the world does not? And it's really hold up for getting a better implementation and better code in glibc. Because we need to make some compromise if you want to move forward.
Yes. Yeah. Well, other people have their hands up, so I'll let other people speak.
It's just two remarks. So one, I think in the last year I reported a bug that was caused by the compatibility code for a new binary. So it shows that that it is real tech debt. Two.
Wait, may I interrupt for just one moment?
Yeah.
I just wanted to clarify that the compat caused the bug. Okay,
I
perfect.
think it was Sid,
Yeah.
I think Sid fixed it. I can't remember the details, but yeah, I think you did. I think you did. Yeah. No. But
Okay.
I'm reasonably confident that there was a bug in a new binary that was broken by some of the
Probably unversioned symbol usage or something, and then the binary got some like an old version of.
I think there was a flag that we didn't set, but I'd have to check again.
Okay.
And then secondly, so our perspective isn't as useful for this because generally our users rebuild binaries a lot and stuff, and obviously we care about ABI, but we're not it's not our main area in terms of people running old binaries on Gen 2. But I can only remember one time that somebody did try to run an old binary and it didn't work anyway because of there was some bug where they weren't willing to give me the binary, but the legacy interface had broken somehow, and this was about 6 months ago. I'm not convinced that it works in all cases anyway. And when I looked at the code, it was gnarly and.
So I agree with you, and I think one of the outcomes there is that glibc is not the only dependency an application often has. And when you have really old legacy applications, the ecosystem around the application mattered. And you're like, well, that application not only just needed the old glibc, but it also needed an old Python or an old libgccs.so or an old something else that had that old existing behavior. And so the challenge will always have been, really, if you want to run that old binary, you need the old environment, and you're going to put it in a VM, and you're going to run that VM environment in that way. And you'll often even want an old kernel, because the new kernels are it's too fast. The semantics are different.
And for such binaries, you can build an old ncurses or something, and actually ncurses supports building for the older ABIs, but it's not enough because the behavior or something has changed in the meantime. So it's
a large ecosystem.
It's a huge ecosystem. Even if you can build something that has the right SO name, that doesn't mean it's going to work.
Agreed. And so then the broader question becomes backwards level binary compatibility as we attempt it. Where's the cutoff, right? What is the cutoff? Because glibc's intent is to provide backwards compatibility for a long time.
So we have kind of done this with the libcmalloc debug, where we have ripped out stuff, put it into a compat library, and have people use that as a preload if they need those symbols.
Yeah.
So I think that is a strategy that we can reasonably look at for libio. Where we rip things out.
Your suggestion is we do what we did for libmalloc debugs
hooks,
in the malloc hooks, which is if you need them, you run a preload. So I guess I have a question for Florian. Or how complicated would it be to make a preload for these pieces? Or I think you've looked at a lot of the pieces here.
I mean, it's going to be pretty large because you have to include printf in the preload.
Yeah.
And I'm not sure. I need to think about if the preload has to actually live inside glibc. But the old code doesn't have a dependency on the white character support because it wasn't there yet. So I think it could be self-contained.
Oh, that's interesting.
Yeah.
Because then it solves Hemmerwall's question about
I'm not sure if we need it anymore because we made the transition of the 32-bit support.
We made
for Red Hat, Red Hat Enterprise Linux 10, we made the transition away from the 32-bit support, and I think IBM is also moving off the 31-bit support for S390.
Yeah.
And that moves all the commercially relevant ABIs past the cutoff point where there was a GCC release that was in principle compatible what we have as ABI today. Because 6 months after we froze the ABI in glibc, GCC changed the C++ ABI, and it is no longer relevant after that.
But as I mean, like, while that is true, as upstream, we do have obligation to users. I think that we made promises to that we wouldn't break those things. But the preload is a fantastic way to say, here's how you can do this
Yeah, but
without much effort.
it is theoretical until someone writes
Correct.
the preload.
Yeah.
I mean,
But if the point of often coming to the BoF is to say, that is a way forward. Because sometimes Ed Hemmerval has nightmares about the printf interface, and maybe he gets motivated to cut it out by writing the preload, and the preload is a concrete first step that you can do.
The question is the preload the precondition for accepting the glibc work? And I would say no.
For accepting the...
Like the cleanups that are not API compatible.
Interesting. So that leads to a question of like, would we make a release without the preloads? Basically, we're saying the old we would only need the preload if someone shows up and says, my app doesn't work anymore, and
I can't
recompile it, and I'm using the new glibc that doesn't have the symbols anymore, and now I need a replacement, and I don't know how to do this. So while I agree with you that it's not a precondition, but yeah.
We should also move to a different topic.
Yeah, we can open the floor.
I was just going to add, related to that, I mean, sort of, is this, support contract? It's like, what are the user expectations, user requirements? I mean, you said you.
What are our obligations to the users of the library?
Is this, this broke? I mean, we'll be happy to fix it for this cost, or we've guaranteed this forever, and now that you've alerted us, and we found the one, binary in the corner that needs it, we'll do it because that's our responsibility.
I think that's up to us to decide. Like you're right. Yeah. Like so. I think at this point, the backwards compatibility with those binaries, the likelihood that those people aren't using a self-contained environment is probably pretty low. I would not make it a precondition to wait on making the preloader, but the fact that the preloader exists, as a leader in the project, I'd love to see someone maybe even mock up if it looks reasonable and post to the list a mock-up, even an incomplete mock-up of what the preloader looks like, could lead another interested party, an interested end user, into furthering the development of that preloader.
So I think that the question of for how long should we support compatibility layer and compatibility symbols is a question about discovery of the user base. And a neat trick that I like about approaching such discovery is add a slip 1 in the dynamic loader for every feature, for every absolute feature, every absolute feature that an application uses. And with each next release, just double it. And if after 5 releases no one complains, you have very good data point that no one actually uses this or cares about it.
We've done similar things in the kernel.
Yeah. Will you be contributing that code?
So we did something similar, not quite voluntarily. We actually broke the old binary support a couple of years ago, and that provided us with a good idea how many people were using it. Quite a few, actually. So we kept it in the distribution for a while, and that meant that we knew that we had to carry forward the 32-bit support for a couple of years more. But nowadays, so we are basically talking about a subset of old binaries for 32-bit x86 only. and that is an extremely narrow set these days. I think the only somewhat relevant piece of software is the Half-Life server code.
Yeah. I think that was what we broke, and that's what raised the bug in upstream.
No, we broke an ISV installer for 64-bit software, but they haven't rebuilt that since 1997 or something like that. Because it still worked for installing the 64-bit version of the software while I rebuilt it. And I think they could rebuild it faster than we could fix the distribution. So, yeah, this is sort of I don't really think this is necessary anymore. And we can prototype the escape hatch.
Yeah.
Like take a current glibc tree and see if I can build an interposer instead of libc ISO6 and see where that leads us. But I don't think that's a prerequisite for like making changes to the implementation right now.
No. I agree.
The other thing is my comments are just about the really old glibc 2.0 API. There have been other API transitions since, and those concern the definition of the standard in, standard out, standard air variables. And that is a separate conversation that I believe there's still new binaries being produced by FPC and other tool chains that actually use those legacy symbols.
Yeah, at Hemmerval, what were you were talking only about the old compat, right?
The thing that has the vtable offset dispatch.
Yeah.
And the vtable
offset code is
the vtables themselves. We want to get rid of that, and instead use some type index or something like that. Yeah.
That gets rid of like 70% of the craft, I think.
Yeah, but you have to add a replacement code for it. So it is not such a. We could the old star.c functionality. We could try removing that and see where that leads us.
Yes. Yeah.
But that is not that much at the beginning.
Yeah. But at Hemmerval's question, like at a high level, someone asked you, what is the biggest block of technical debt that we had in the project? And I do think Standard.io Common and libio has quite a bit of technical debt with some blocker there. Well, you have your hand up. Or yeah, at Hemmerval.
So my next question is, how upset or are we going, if I suggest to just remove this old libio symbols from the next release or from the 244?
I think the answer was...
I won't change the implementation. It's just let's get rid of and just export the new interface that without this VIO table and VIO symbols that uses old binaries.
I think at this point, there's enough distance between us and the old binaries, and there's enough ways for people to run compatible systems. Like I think you would just run a VM and run those binaries in a VM, and it'd be way safer and way better for you. I don't think we'd block on removing some of those old symbols. We would have to, obviously, you write a good news announcement. We try to circulate it amongst the users and the distributions that we're doing this. I think there's a little bit of precursor work. So I mean, the best previous examples from these things is like when we did the SunRPC transition to TIRPC. We did not do a good job of like working with the ecosystem to do that transition. And it took us 2 or 3 attempts to do the transition. This is going to be way easier than that, but we should still, I think, pre-notify people that we're removing some symbols because people will see it and go, oh, glibc is removing backwards compat, like why? And won't look at the details of those symbols and the implications and why. They'll look at like a high-level news story, right? Like, what would be the title of a news story if you wrote it like, glibc removes backwards compatibility only for these symbols on i386, and you can run a VM that are like 35 years old, right? Like, there is the headline side of like symbol removal that just happens. So I'd love to have us get ahead of that and say, yeah. So Florian's got his hand up.
I would like to move on to a different topic,
Do it.
also about backwards compatibility. So we recently tried to address the technical debt in the TermIOS interface we had.
Oh my. Yes.
And I think we botched it and didn't introduce new symbol versions.
And didn't.
Yeah.
Okay. You think we should have introduced new
Yeah,
symbol
because
versions?
that allows us to have applications go down different paths based on their age. And that allows us to constrain workarounds to the old applications. And right now, we have to guess what's going to be compatible with new applications and help old applications at the same time, which is not an ideal position to be in. And I posted a proposal for a point release with the new symbol in it. And
Would you like to do that?
HBA has some issue with it. I don't know if you.
I saw HBA's comments. He didn't like it, but I don't really see what the alternative is because, yeah, I mean, we don't need to do the tweaks the way I suggested. We can do the tweaks in the way he suggested. That's totally fine. But we have, once we introduce the symbols, we have a way to bifurcate the behavior based on the age of the application, and that makes it, after that point, we can try various approaches. It doesn't look good on our resume, but it is possible to solve it because we have a technical path forward. Right now, it's just guessing. We tweak this bit here, and it improves compatibility with old applications, but does it help new applications that have different workarounds by now? We don't know.
So what do we need to do to fix that today? Do we need a point release with symbol versions and then get the point release into the hands of the distribution so that it's present?
So I reviewed that his patch on the premise that it's supposed to fix the bug that we have on the bug track. So did it fix it, or are we still seeing issues from the users?
I don't think they landed yet.
No,
But they don't solve the whole problem.
No, it's all.
Yeah.
So
But as Florian says, if you have the symbol versions, then basically all the old applications run against one implementation, and you can tweak all the knobs, and all the new things run against the new implementation because they got rebuilt, and you can tweak all those knobs differently from the previous knobs that you tweak, and you can attempt to experiment, and you enable the experimentation to the point where you can try to find solutions for both old and new.
Did you see what HBA had said, though?
No, I didn't yet.
His argument was that because you have the kernel boundary between them, if you have one application using the new interface and one using the old, that they're not necessarily going to interact in expected ways. But as Florian said, I don't know if there's an alternative, really. So I haven't got a better idea. So.
The symbol versions do not preclude doing this. They just add an extra ability to experiment on a per symbol version basis with the parameters that you'd have added.
Yeah, and the thing is, what I'd like to see is that the new versions don't do any tweaking and present the kernel interface as closely as we can, because we know that doing it differently is going to lead to problems down the road for us. On the old symbols, we can do whatever is necessary to try to put what we find in the kernel state and make it digestible for the old applications. And what HPH is trying to do is goes in the other direction. When setting the state, he wants to tweak things so that it works the old way. And if we and yeah, I mean, it is. I don't feel comfortable with that approach, because that means the old compatibility code will stay for us forever, because we don't have a way to remove that at any point. Yeah, and what we need to do is, I think we need to announce our plans on libc announce for the distributions that are not in this room.
You mean
like pre-announce what's going to happen if we have some confidence what we are going to do, and then have separate patches. First introduce the symbol version without changing the behavior, and we can do targeted rebuilds of distributions against that, so that the new applications move to the new symbol without changing the behavior yet. And then we swap out the behavior for the old symbol and in a separate patch, and then distributions know that they can then apply that after they have upgraded their binaries that use the new symbol now.
Yeah. From a big distribution perspective, so I think we've got Fedora Gentoo covered here, but Aurelian we haven't included, so there's Debian and all the other smaller distributions. Is there anyone from Debian? I don't think so. Yeah.
Yeah.
But it's fine. I mean we can post to the list and involve everybody.
Yeah,
and we have the
for Fedora, it's at most 1,000 packages we need to rebuild, so it's not too bad.
Yeah.
It's a bad release for us because we had 2 Python mass rebuilds already. But
we, as part of the GNU toolchain update in Fedora, I think we always request a mass rebuild in order to kick out any symbol or ABI issues. So we can also go to the release engineering team and say we want a mass rebuild for.
Except that the distribution is shipped by that point.
Yeah. Yeah. That's a off the side approach for other things. Sid.
So new topic. So we've had funding from funding budget from the OpenSSF for a while for infrastructure. And I feel like companies don't keep their budgets forever. So I feel like the clock is running out on that. And we've kind of gone back and forth on what we want to do there. So what are the next steps?
I have a slide for this. So glibc is currently using sourceware for infrastructure. Again, I'm immensely thankful for all the things the sourceware volunteers do. One of the things that I'm going to say is the clock doesn't run out on us. The clock might run out on funding from the OpenSSF, but that doesn't mean that the clock runs out on companies that value the GNU toolchain, companies that are willing to sponsor, companies that are willing to support us. It also doesn't run the clock out on, we need to improve some of the security best practices we have in upstream. We have a lot of people with write access to our repository. That's not sourceware's fault, right? To some degree. It's also not CTI's fault or infrastructure's fault, but there are projects that we can make forward progress on. I would like to have us determine how we make that decision, right? So Alex is in the room as well. Alex has some concerns about like CTI versus sourceware and how we make that decision. Ultimately, when we put CTI together, our goal was to meet the GNU ethical repository hosting criteria so that you can host things on free and open source software, right? And so it does leave open the question of how do we change the infrastructure that we're using? And that, like, I think today that's the open question, is like, what infrastructure do we want to use and how do we change it? What do people think? What's your opinion? Mark? Hold on, we'll get the mic. Yeah.
So if you looked at the forge for if you want to change infrastructure anyway.
Say again, the forge?
Yeah, that we started last year. Claudio and I will have a BoF tomorrow. Yeah, tomorrow on the forge. Is that infrastructure that you like or not?
That's a great question about Forgio. So if I put my GNU project maintainer hat on, Forgio is missing some pieces around, I think, JavaScript, accessibility if the client side doesn't have JavaScript. So under the GNU ethical repository hosting criteria, when you have certain things disabled, the functionality still needs to be there. And so in truth, the only Forge I'd seen that met the GNU ethical repository hosting criteria was Pagure. and a lot of work for Pagure.io, which Fedora is using, met the requirements of the GNU project as it defined those criteria. So Forgio, so taking all my hats off, I love Forgio. I really like Codeberg in the model that they've gone to, where they have the German EV and they're accepting funding and they're trying to sustainably fund the development of the Forge and those models in a way that supports FOSS projects, unlike the other pieces. I still don't think that Forgio, as it is, meets the community's current requirements for how they're doing development. And it would be hard to see that integrated with our current workflows. But I hear you. That is, you're saying, what about Forges? In our Forges, another model. Forges have security issues in my mind because they form singular systems that are boundaries and blocks for your development, right? Florian.
Can't we solve the compliance issue by disabling the web access to the repository? And then just use the Git backend code from Forgio, assuming that is better hardened against committer access?
That is possible.
I mean, it's a bit strange, but that means we could stick on sourceware and address your...
So there are two aspects to this that we should discuss, which is sustainable funding for infrastructure, right? So where do the sponsors come from? How do we get those sponsors to contribute? And Sourceware has at the SFC has the project, and they can receive funding. And I've spoken to Mark and I've said, it's really hard to get sponsor money, and that's just a difficulty, right? It's often hard to get sponsor money directly. Sorry, Florian.
I thought we were talking about technical.
This is
Two pieces. One is sponsors. The second is, with that money, what do you do? And what you do is get paid support for that infrastructure from a technical perspective in order to set up the isolations that we want to see to harden the infrastructure. And so it's a lot of work today to create modern infrastructure with these levels of isolation because of the machines you need, the space that you need, and the layout for those machines. Sid.
So my original question wasn't just technical. It was more of how do we scale? And for scaling, we need funding. And that essentially was the base of my question. It's not about whether we use Git or Gitolite or Forgio or anything else. It's about where we host it and how we can securely isolate all of the instances, how we can scale across all of those services and all of that. And I don't see a funding direction. And we have a funding budget available, which we are essentially rejecting at this point. So that was my question, really.
Yeah. Mark or Claudia can answer. Yeah.
Sourceware does indeed have funding, maybe not as much as we like, but we are making progress. So some of these things indeed would move forward faster if there was more funding. So the Sourceware Project and Leadership Committee made a couple of projects that would move forward faster if we could hire somebody to set up some extra containers. But it's first, we do have some funding, so we can refresh hardware and while we are doing that, these isolation projects move forward just not as fast as we might like. this funding you say is available. Could we as Sourceware say, okay, we have a couple of projects that could increase isolation, and we could hire people to do that. Would that help?
The idea is to use a slice of an existing team that is implementing secure infrastructure for the Linux kernel. And to maintain such a team is really expensive. I do think that today, administering and running our infrastructure continues to become expensive against security threats like all the AI crawlers. I know that you guys have spent we've spent a ton of time combating that. And so the way in which I recommend that that money gets spent is to borrow a slice of a team. Today it's the LFIT team because they're maintaining kernel infrastructure using FOSS. And that money is basically a portion of that team, and they're skilled at what they do, and they've been doing it for the kernel, and therefore we would be leveraging a slice of that team. To use the same amount of money to pay partially for another IT team, I don't think yields the same security benefits, doesn't yield the same isolation, doesn't leverage that in the same way. I get what you're saying. You're saying, can we use some of it to improve security? I think
we have plans for that, which we can execute and are executing just slowly. It's you seem to believe that we have to move out all volunteers in the infrastructure to get to a point that is acceptable?
We don't need to remove all volunteers to get infrastructure to a point that's acceptable. I think that a core portion of the infrastructure, we need to pay developers, IT, and operations for maintenance of that secure infrastructure. I think to some degree, we're being unfair to some of the volunteers that we have for the amount of infrastructure we have to maintain, and we can leverage people that are interested in supporting and sponsoring the project for that infrastructure. Now we're only talking about infrastructure, right? So, but that's a broad perspective. We're out of time, but I think we should continue to have this conversation on the list with the rest of the developers.